Good evening, y'all. Welcome back to another Sunday night electronics bash. Fundamentals of electronics and C++ and Arduino and Python programming and adjusting audio levels when we see we're clipping. It's a whole shebang. I'm Jeff. It's good to see you all again. Tonight we're going to take just a little half diversion of what we've been talking about over the past few electronics bash sessions. Namely, we've been focusing very specifically on Raspberry Pi oriented Python. And as this is the holiday season, and as this is the time of year of advent of code, I thought it might be a fun thing to do tonight. So in the off weeks, as many of you know, I have been working on some personal projects that are not Raspberry Pi related, including these little guys behind me. Hey, Nate, good to see you. And what's hard for me to internalize, although people keep saying it, and I think it's true. And hi, Chris, good to see you too. It's, as people have pointed out, especially in the Demi-Lite streams, is that watching the troubleshooting process and the problem solving is actually kind of useful and interesting. So I thought we might sort of take that idea and run with it. And what we're going to do tonight is I'm going to go over the solution, at least my solutions, to the first 5 days of advent of code that we've seen so far. Hey, Palmer. Hey, Katie. Hi. Just to like show you the problem-solving skill set there. If you're following along, if you've been doing those challenges, super cool. Maybe this is helpful to you. If you aren't, maybe this is a good idea. It's like an introduction to like how to approach those problems. We're gonna kind of breeze through those a little bit. I want to point out a couple of specific features of Python that I don't think I've talked about before, and then I'm not a super expert on, so I'm pushing myself to learn more about them during this advent of code time, so I think it'll be a really fun thing to talk about. And then, so that'll take us, not super long into the evening. And then we're going to try and solve day 6, today's problem, together in real time, which I have not looked at all. So I'm excited to like look at it for the first time with all of y'all. I sort of thought, so my usual MO, and I'm vamping a little bit to give any late stragglers a chance to catch in? It's fine. Chance to catch up before we dive in. But my usual MO for these challenges is I find it useful to read the problem and then let it mull around in my brain for a little while. The problems come out every night at midnight Eastern, so 11 p.m. here Chicago time. So if I'm up, I'll usually read the problem the night before, and then sort of kick it around in my brain and think about different ways that I could potentially solve it and go to sleep, get up, have breakfast, and by the time I start working on the challenge the next morning, I sort of have some thoughts about how to approach it. And so what I had thought I was going to do for day 6 today was look at the problem last night, kick it around all day today, and then kind of walk through what I thought the solution would be today live. But I actually think that musing part, that sort of like architecting, working on the process, thinking about how to solve the problem is actually really valuable. So I figure we'll kind of do it live, and we'll see how it goes. Yeah, Palmer, my lighting pipe back here is smiling just a little bit. Hilariously, so it was originally just a singular quarter-inch poplar dowel, and it was really bending, and I was like, oh, I'm very clever. What if I just, put the second dowel on top of it and tied them together, like zip-tied them together? And then I realized what I had invented was like a double batten. A ladder batten. I invented a ladder batten, or a strong-backed batten, which people have been doing for decades. So not terribly creative, but there's little cute, you probably can't see them, little 3D printed brackets just here holding them up. If that little dot is 3D printed, I swear. Anyway, having a great time. I may switch those off later. I don't know if you can actually hear those on my microphone. They do make a little bit of servo noise, so if they're annoying visually or audibly, let me know and we'll switch them off. I just wanted to show them off because I'm super happy that they work. So that's fun. But yeah, let's just get right into it. A couple of things tonight. We're going to be, of course, looking at the Advent of Code website and also the code editor that I use nowadays when I'm programming on Windows. So let me know if there are issues seeing either of those things, because we haven't really looked at both of those before. In terms of text size or anything like that, I can try and tweak them. Will they light the blinds on fire? I hope not. I think they're running at like max 10%. And actually, unit 3 just here isn't moving at all. I think I've unplugged. Yeah, I've unplugged that one because it has some weird pan issues that I haven't diagnosed, and I probably never will because it's like 2 generations old. But yeah. Anyway, let me know if you can't see anything. We'll figure out a text size that works. Let's just get to the code. Yeah, I think we'll have a good time. Hopefully, we don't break too many things. So yeah, let's get into it. So here is the day 1 challenge from Advent of Code. And then I'm just going to sort of talk through briefly what the problem statement is. There's a lot of really delightful flavor text in all of these. This year, our theme is we're taking a nice vacation at a resort on a tropical island. Oh, speaking of tropical island, thank you, Nate. I didn't share my beer for the evening. I am drinking, I didn't think I was going to use this top-down cam at all today, but a Mothership Wit from New Belgium Brewing Company. Just like a basic wit beer. It's real tasty, real refreshing. Yeah, my wife and I are doing a beer advent calendar for the holidays. We've had all kinds of like weird and interesting beers in the past week, so it's kind of nice to just have like a basic, delicious wit beer. If anyone's drinking anything interesting out there tonight, I'd love to know. As always, no pressure to drink, but if you're not drinking, hydrate. You'll never be sad that you hydrated, I suspect. All right, so where were we? Thank you, Nate. Problem statement here. So the first part is just some flavor text and telling you that there'll be 25 challenges and each one is in 2 parts and you'll get 50 stars, one for each part over the course of the month. That's basically the same every year. In this challenge of part 1, before I go on vacation, the elves in accounting just need you to fix your expense report. Specifically, you need to find the 2 entries that sum up to 2020 and then multiply those numbers together. For example, suppose your expense report contained the following, and they give you some sample numbers here, a little sample short list, and says, in this list, there are 2 numbers, 1721 and 299, that sum to 2020. So in this case, the answer that you would provide, and normally when this is in puzzle mode, you submit your answer down here. In this case, because I've submitted the answer already, it tells me that my answer was something. But it says for this list, with these 2 numbers, my answer would be 514579. So in my puzzle input, of course, is a much longer list, find the 2 numbers that sum to 2020 and input the 2 of them multiplied together. So if we take a look at our puzzle input here, and this is, I think, different for everybody, it's just a long list of numbers, and presumably there's only 2 of them that sum up to 2020, and we've got to find them. So there's a couple of different ways we could solve this coding challenge. I'm going to jump over here to Visual Studio Code, which is the IDE I'm using nowadays. I think when I've talked about using integrated development environments on Windows before, I've been using Sublime. I switched to VS Code a few months back, and I really like a lot of its built-in functions. So this is the one we're going to be using today. How is this for visibility before we get too deep? The code and also the terminal down here where our results are going to print out. I can munch with either of them. I can change either of them if we need to. Yeah? So do let me know. So the solution to part 1 here actually implemented in a couple of different ways. And I'm actually going to build a third way as we go. One is, so I'm basically down in my main method down here, which we talked about before. I'm going to say for the solution to day 1, run either the naive find function or the dict find function. And for the solution to part 2 that we'll see in a second, run the naive find 3 function. So let's look at what those functions actually do. So the naive find function just starts a new list, opens up our input file. And my file in this case is going to be input.txt, and I can pull that up here. So that's just the copy and pasted list from the website. Opens it up, and for every line in that file, and this is kind of what we talked about last week in our working with files chat. For every line in that file, we're going to add a new item to our list, which is that line stripped of any new line and carriage return characters that might be on there. And this strip function just takes anything off the beginning or the end that matches anything that's inside of these parentheses. /n, you'll remember, is new line. /r is carriage return, which sometimes you see in files that have come from a Linux-based system, but this is just to be safe. I'm take the integer version of that, because I really want this data to be numbers and not like numbers stored as strings. And I'm going to store all the numbers, basically store all the numbers in a list. And this will be a common theme that we do for most of our problems, is like take the data, get it into a list so we can do something with it. And then for every item in range length of data. So basically I'm going to go over all of the data. I is going to be 0, 1, 2, all the way up to however many data points we have. And then I'm going to look at every following data point. So we're going to go from range from I to the end of our data, right? Because in the case of our problem statement, if this item plus this item equals 2020, then the same as this item plus this item equals 2020. We don't need to compare anything earlier in the list because we will have compared to it already as we move through our loop. Does that sort of make sense? So we'll compare basically each pair of items in our list, and if they sum to 2020, call this success function, and then return. And the return here, recall, remember, exits immediately out of whatever our function is. So I'm going to basically return out of naive find to say, once we found a match, we don't need to look any further. This success function here is just a little utility function I wrote, which takes some numbers and basically prints them out saying, I found that these two numbers sum to 2020. And as you can see, I was running this code to test that it worked before the stream. You can see in my case, it printed out, it found that 631 and 1389 sum to 2020 and their product is so-and-so, right? So as we are looping through our data, we found the numbers 1389 at position 162 and let me find 631 at position 143. We added them together, they were 2020, and so we printed that number out so I can type it into the website. Cool? Just looping over a list, doing a little of data input, and if our condition is met, then we print out the success. Yeah? With me so far? The second way that I chose to solve this problem, which just avoids one set of loops, and that's going to be a common theme tonight, is like trying to avoid looping over things multiple times. I'm basically going to say for every time I'm going to start a new dictionary this time instead of a list, and for every line in my input file, I'm going to take it as an integer, right, not as a string, and I'm going to find its complement with respect to 2020, so 2020 minus the number. If the complement is already in my dictionary, if I've seen it already, then I'm successful because I know that my number and its complement have already been seen in this list, right? So this list is ultimately going to contain each of the numbers in turn as I read them in from the file, right? So I'm going to load a number, I'm going to store it in my dictionary, and if I see that it's this number that I'm looking at now already has its complement with respect to 2020 in my dictionary, then I'm done. And I do this with a dictionary, and I could have done it with a Python set as well, which is very similar, is that comparisons with a dictionary are very fast, whereas comparisons by adding two numbers together are just a little bit slower. So this is just a way for me to see, like, if I were to do this in a way that I'm only going through each number once and comparing it with the numbers I've already seen, does this actually speed things up? And I wrote a little bit of code that I won't go into tonight, but if you look down here, you'll see the naive find function, that first function we wrote, took 1.7 milliseconds to complete, but this second method that only looks through the number sort of once, comparing it with everything it's already seen, took half a millisecond, so about 3 times faster. Now, I don't know about you, for the sake of these coding challenges, I don't care about a millisecond versus half a millisecond, doesn't really matter. But as we get into bigger coding challenges, if we were talking about a minute and a half versus half a minute, then I might care about these kind of optimizations. It was day one and I was feeling my oats and I thought I would just take a whack at doing it 2 ways. So there it is. I should say, as always, ask questions if you got them. This is a pretty casual night, so feel free to jump in with why this or how that. I should also say, Advent of Code, the website, is linked in the description down below. So if reading the problems on the screen of the stream is not super good, you can just read them on the website if you like. I've also put a link both to my GitHub, where all of this code is being put up, and the blog post I did for both day 1 specifically and days 2 through 5 that has a little bit more explanation and thought behind this code. So if you find either of those formats easier to follow along on the code with, or are interested in reading them, they're all linked in the description. Now you know. That's all linked to on jeff.glass/electronicsbash as well. All right. So that was part 1. And we'll go a little bit faster now that we have a little bit of a sense of what Advent of Code is, I suspect. Part 2 says basically the same thing, but find 3 numbers that sum to 2020, multiply them together, and report their output. And similarly to how I solved part 1, I'm basically going to just loop over all of the possible triplets of data using these 4 functions, and if their sum is 2020, then again, call that success function, which is going to print our numbers out to our terminal for us. And I find that 708 and 140 and 1172 sum to 2020, and their product is what is this? 116,168,640. So not a particularly efficient way to find 3 numbers, but I didn't implement any kind of clever math for this second method. And you can see down here that I kind of pay the price because, let's see, did I do timing on this one? Yeah. So where this first function took a millisecond and a half, to find this triplet of data took 8.2 milliseconds, about 6 times as long. So not the worst, not the best, but again, our data is manageable. If we were looking at thousands or millions of entries instead of just 200 here, we might have to think about optimization. For the sake of solving a problem, totally fine. So that's day one. Nothing terribly hard. The nice thing about Advent of Code as a challenge is they really kind of ramp you into these things. This is essentially like, do you know how to read values in from a file and iterate over them somehow in your language of choice, right? Nothing terribly complicated. Can you add 2 numbers together, check the result, and then print out, print out a thing as you're looping over a loop. Totally cool. Let's see. Let's go to day 2 real quick. The gist of day 2 is that you have to help your travel agency tell whether their passwords are correctly stored. So you're going to get an input file that looks like this. It's going to have 2 numbers separated by a dash, a letter, and then a string of letters. And in part 1 here, the first part here is the password policy, and the second part is the password to validate. In this case, the numbers mean the lowest and highest number of times that a letter is allowed to appear in the password. So in this first example here, we're allowed 1 to 3 instances of the letter A. So this is a valid password because it has 1 A. This is not a valid password because it only has no character B. And this one is valid because it has 9 letter C's and so on. This is also a nice thing that like Advent of Code does. That's a good thing to think about for your own code is unit testing. So rather than like testing your code on the giant input file that we're going to see in a second, write some very small test cases, some which pass and some which fail, and make sure that your code is behaving right on a little subset of data that you can easily modify before expanding it to a giant set of data. So the first part of the challenge here says how many passwords in your input file, and of course a different input file for day 2 because it's a different question. How many of them are valid according to the rules given in the file? So to solve that problem, we'll close out day 1. We'll open day 2's code. Excellent. So let's see. So this is actually a much more condensed bit of code. Let's come down to the part that's actually executing the code, and we'll work our way backward. So you can see down here I say, print the solution to part 1 is, and then we'll do some things, and the solution to part 2 is, and then we'll do some things that give us our answer. So what are those things? And here's where, this is actually one of the things I'm excited to share with you tonight, is we've got a new coding concept built in here. So let's take a look at what we're going to end up printing out as the solution to part 1 and part 2 of the day. And we'll get to part 2's challenge in a second, right? Just looking at part 1 here. So we know we're going to print out the solution to part 1 is, and then we'll take the string version of some number that we get out of our calculation, and that number is going to be the length, we know the len function, of this. But this is a new construction for us. Let me just copy and paste this into a new file here. This is something we have not seen before. We have open square brackets, line for line in data, if is valid line, line is sled valid, close quotes, close parentheses, right? So this is something we haven't seen before, and this is something called a list comprehension, which is an easy way of forming lists of data in Python from other lists or iterables. Let me show you what I mean. Let's say we wanted to create a list of the first 10 square numbers, right? So 1, 4, 9, and so on. There's a few ways we can do it. The way we would have normally done it, given what we know so far, is something like square nums equals an empty list. For I in range will go from 1 to 11, right? Because we don't include our second argument here. So this will go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Square nums dot append I times I. And then let's, at the end of this, we'll print square num so we can see everything that's in it. Oops, I gotta save this somewhere. Let's save this as just a bit of scratch file there. And now I'm going to need to go find it in my terminal here to execute it. There we go. So we see that our result we get out is basically what we expected. We get 1, 4, 9, 16, and so on, because as I went from 1 to 10, we were adding I times I to our list, right? This should be relatively straightforward. This is all constructs we've seen before. Let me show you how we would do something that's exactly like this upper part, but with list comprehensions. Let me comment all this out. I'll type it all in, and then I'm going to go back and break it down a little bit for you. So I'm going to say I times I for I in range 1, 11, right? And if I run that code, you'll see, oops, here, actually, I can condense all this as well. Let's just put that all in a print statement. Put our other print statement up here and comment it out. If I run this, we see we get exactly the same result, 1, 4, 9, 16, 25, and so on. So this is an example of a list comprehension, and the structure of it is, and I'll comment this out because it's going to be kind of talky code, right? It's going to be something like expression for index in some iterable. Now, what do those things mean? So basically, this indicator here, this I, behaves a lot like the I in our for loop. It's going to successively take the values out of whatever iterable is here. This could be a range statement, this could be another list, basically anything you can use in a for loop. So I is going to take the successive values from here, and then each of the values of the expression at the beginning of our list here will be stored into our list. So if I say print 2 times I for I in range 1 to 11 and run that, I get 2, 4, 6, 8, 10, and so on. If I put I mod 10, that's 1 mod 10. If I put I mod 10, then I get, well, I don't get anything particularly interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, right? Because that's the numbers 1 through 10, mod 10. If I do, let's do I squared times I squared mod 10, right? I get 1, 4, 9. This would be 16, so mod 10 is 6. 25 becomes 5, 36 becomes 6, and so on. So anything that I put here, so this is the expression that's going to be taking in the values of I as they range over this iterable, and this is what's going to be stored in our loop. With me so far? So we can use as this iterable anything we could put in a for loop here. So we've seen examples before, like, let's make a list of names: Palmer, Jeff, Nate, and Chris. Oh, let's get Katie in there as well. Let's say I wanted to store the first letter of everyone's name in a list. The one way we could do it is say first letters equals list for name in, I should probably give this list a name, my names. For name in my names, first letters dot append, name 0. Then I'll get the very first character of each of those names. And then when that's all done, I'm going to print first letters. All right, so if I run that code, I get PJNCK for Palmer, Jeff, Nate, Chris, and Katie. Great. So again, just an easy way of looping over the list that we have in Python. But if I just need, a quick way to put this list together, I could also write this as a list comprehension. I could say print. I'll open my list here at the same square brackets that I used to define my list up here, right? I could say print name 0 for name in my names. And if I run this code, I should get the same thing twice. So I get PJNCK, PJNCK. Yeah? Is this concept sort of making sense, right? We're letting this value range, this name, this variable name, range over all the values in this iterable object. And I know I've been tossing out this term iterable, which does mean has something very specific in Python, but it basically means anything you can step through, anything you can iterate through. So a list or something like the range function that automatically goes from 1, 2, 3, 4, 5. Nate says, how would you make it show the whole name again? Good question. So if you want to just duplicate the list, for example, I could say, so in our loop example, right, instead of just appending the 0th letter of the name, I could just append the name to the list, and we'll see we get Palmer, Jeff, Nate, Chris, Katie. Down here, I can do the same thing. Rather than appending the 0th letter, I could just say name for name in my names. Yeah? I can do sort of any operation that I could do on strings down here as well, right? Remember, we can concatenate strings with the plus sign. So I could name plus, and let's add a string, is cool. And now our list comprehension will say Palmer is cool, Jeff is cool, Nate is cool, Chris is cool, Katie is cool. Yeah? So anything sort of that we can do within a simple for loop like this, we can do as a list comprehension. So why would we use this as opposed to this? Well, in the situation where you just sort of need a slightly modified version of a list for a single operation, this is just more compact and I think a little bit more readable than this. There's nothing you cannot do with, you don't have to use list comprehensions, but they're a nice little compact way of doing some problem solving in lots of cases. Yeah, I will mention offhand, although I don't know that we will see them today, that you can do the same thing with dictionaries and sets. So I could say, I see you, Palmer. My cool points is going to be a dictionary. And let's see, how do I want to do this? Okay. Let's use our my names list again here. Let's say I want to assign coolness points based on the number of letters in somebody's first name, and I want to store that info in a dictionary. A very silly example, but as a loop, I could say cool points equals a dictionary, and for name in my names, cool points with the key of name equals the length of the name, right? And print cool points, right? So here, let me comment these out, just so we're not running more than we mean to. Oops. Extra colon there. If I run that, I get Palmer. I mean, Palmer, you do have the most cool points, so I think you are certainly cool. Nate and I holding up the bottom. Chris and Katie, sort of silver medalists there in cool points. So we can also do the same construction as a list comprehension. I could say cool points. Let's give it a different name. Say, I'm not going to just reassign this. Cool points equals, and I'll use my curly brackets this time because it's the same way I'm defining a dictionary. And will be, I need a colon here to separate my key and value pair, just like I would be, defining a regular dictionary with. I could say that name references a value of len name for name in my names. I think this will work. And then we should print this out. Again, print cool points. So hopefully those two things are the same. Yeah, there we go. It's being made these cool points too, just so I can prove to you I'm not just reusing the same dictionary, right? So remember when we define a dictionary, we have our key and the value that it references. And again, so this name here is just going to loop over all the values in my name. And when it does, it's going to add this particular value to the dictionary. Now the key doesn't have to be the name. Does your full name? That's true. I should be using people's screen names here, their pen names, but Palmer was looking a little down in this comment always. I want to make sure that Palmer's up there because he's a pretty cool guy. We could also, we can do any operation on these variables that we want to. So I could say, name times 2 times. Here, maybe the points are the square of the numbers in your name. Not that it's going to change our rankings any, but Palmer now has 36 points. Me and Nate get 16, and Chris and Katie get 25. And this is just a normal dictionary, right? This is just another way of creating a dictionary. So I could always say, cool points 2 with a value of Jeff equals 1,000 after the fact there. Just assign a value to the key Jeff in my dictionary. And then when I print this out, I have 1,000 cool points, right? So there's nothing mystical or temporary about these dictionaries. There's just a faster way of defining them. Or not even a faster way, a more compact way of defining them, especially for simple constructs. Yeah? Cool. I bring that up because that's the construct we're going to be using in the solution to day 2 here. So we remember that back in our problem set here, I said the solution to day 1 is some string version of the length of this list. And what is this list? This list is composed of the line for line in data. So basically every line in our input data, if the function is valid line with the parameters line and is valid sled is true. So what is this construct here? Line for line in data if. You can also apply conditionals to your list comprehension. So I can say, let's say I have a list of all the names, but I don't want to necessarily assign myself cool points because it's kind of a gauche thing to do, I will admit. So I could say cool points is equal to a value of name, referencing the score, the length of your name squared for name in my names, if name not equal to Jeff. Right? And now you see I've disappeared from the second dictionary. I've not assigned myself any cool points at all. Maybe there's a check here instead to say if your name is too long, you don't get included. Maybe it's a spam name. So I could say len name for name in my names if len name is less than 20, right? And then maybe if some spam input got into our chat here, like I can't think of anyone with a long name who is not a real person. Let's say Santa Claus, the most jolly elf, right? So, right, though Santa Claus, the first jolly elf, of course, made it into our original structure up here where we were just iterating over everybody. Down here, because the length of his name is greater than 20, he does not get iterated over and does not get put into our dictionary, right? So we're allowed to put conditionals on whether things get put into our list or not. Yeah? So that's what I'm doing here. Basically saying, I want to count up the number. Remember our problem statement back in the day was how many lines of my input are valid. So I'm going to say, okay, well, make a list basically of every line that is valid, and then use the length function to just count up the number of things in that list. So make a list of the lines for line and data. If it is a valid line, I'm going to call is valid line is valid sled, right? So what's going on here? So let's go look at the is valid line statement. It's up here. It takes a line, and this is something we actually haven't seen before. It's a function. Maybe I've talked about this a little bit. This function is going to take our input line and split it apart. Right, so our input lines look like this. I'm going to split it everywhere that there is a space. And this is going to return to me a list of things split apart into three, in this case, 3 items. So each line I'm going to get, for example, 10, 11, then a list item that is B colon, and then a list item that is the rest of this, because we want to treat these things differently. Then, according to our problem statement, we're allowed to have no fewer than this first number here and no more of a particular letter than this second number. So I'm going to use another list comprehension. I told you they were going to come in. To say, make a list of the integer version of x for x in contents dot split dash. So what does this mean? I'm going to take the first member of my list, which is going to be this set of numbers here, anything before this first space. I'm going to split it in half on either side of the hyphen. So say 10 and 14, 11 and 13, and so on. And then I'm going to take the integer version of it and make it into a list. So I'll have a list that is 2 items long. It'll be, say, 9, 10, or 3, 4, or what have you. And then here's, I guess, another Python feature we haven't looked at is multiple assignment. I'm allowed to say that this variable name and this variable name equals this list, and this variable will take the value of the 0th member of that list, and this variable will take the value of the higher second number in that list, if that makes sense. Yeah, I guess a lot of new features of Python that we haven't talked about before, but super handy. Then I'm going to find the letter that I need to find by stripping the colon off of my second member of my list. So strip the colon out there. I'm going to strip the new line off of this third line, this password here, so I just have the letters. And then I'm going to do one more clever thing, which is I'm going to return the value of func, a function, given these parameters: low bound, high bound, password, and letter. This is a thing we haven't, I don't think we've talked about, and I apologize, there's so much more new stuff here that I'm excited about. You are allowed to treat functions as what's called first-class objects in Python, which means you can treat functions as objects. So you remember down here, I said the solution to part 1 is line for line and data if is valid line, and I gave it the line I'm working with, and I gave it the name of a function. It said is valid underscore sled. So this took in the line that I was working with, just the text of that line, and a function name. And then at the bottom of this function, I'm just going to call whatever function I passed in, given these parameters that I've calculated already, right? And this is going to allow me to reuse some code, because as it turns out, in part 2, what counts as a valid password is slightly different, whether you're looking at the sled slope on the hill or the toboggan slope in the flavor text of the thing. So rather than having to sort of redo this splitting apart into different pieces code, I just said, okay, well, in the first part, validate using this very simple, if the number of the specific letter in our password is greater than or equal to our lower bound or less than or equal to our upper bound, then things will be true. If they're outside those bounds, it'll be false. In the second part of our question, we are asked to, one or the other of the positions specified by the first and second number must be the letter. So, for example, in this line, this is saying that either position 8 or position 9 of this password, but not both, must be a W. Right? In this one, either position 1 or position 10 of this line must be an H, but not both. So this is the validation function for that. Here's our exclusive OR function. You might remember back from like Arduino class days, right? So if the letter in this position equals my input letter, exclusive ORed with the password in this position equals letter, then return true, otherwise false. So I'm making a list of all the lines in the other case that are valid according to my given rule, and then printing out the length of them along with the solution to part 1, solution to part 2. So if I run this code, and I'm going to need to get back into the file in my command line here that it actually is. CD code advent, cd day 2, python day 2.py. I see the solution to part 1 is 398, and the solution to part 2 is 562. Happen to be those for my data. Questions so far? I feel like this is a lot of new stuff. And I'm just thinking through my solutions the next few days. I don't think there's that much that's new conceptually in the next few ones. But if we hit 45 minutes in and we haven't jumped to today's problem, I think we should probably just get to it, because that was kind of what I thought we would get there earlier, but apparently there's a lot of cool stuff to talk about early in the night. So yeah, question. I think I said this earlier, but we have been drinking so many. We had like a caramel stout, a caramel marshmallow stout yesterday as like our Advent beer. And so just to have like a basic wit beer is like, it feels it's almost like a La Croix at this point. Like, it's very refreshing. Sort of very, very simple. I like that a lot. Yeah, let me take a quick spin through the next 3 days and think about, I don't think we're going to talk about days 3 and 4 and 5. Think about which of these might be most interesting. Oh, I know. Let me show you the solution to day 5, yesterday's challenge, because it's very concise, and will kind of show the power of list comprehensions. So the challenge for day 5 was, remember our through line is going on a tropical vacation, a well-earned tropical vacation. And rather than boarding the plane by groups or zones, the boarding passes specify your position by binary space partitioning, right? And it explains what this means, right? The first letter on your boarding pass, every letter is either an F or a B. The F means you're in the front half of the remaining seats you're considering. The B means you're in the back half. So let's just scroll down to their example here. Let's say you had this boarding pass FB, FB, BFF, RLR. Right, so the first F means that we are in the first rows of seats, rows 0 through 63 in our case. Then the B means we're in the back half of those, so rows 32 through 63. The next F means we're in rows 32 through 47, and so on until we've specified exactly one row. And this ending RLR here specifies that we are on the right half of the plane, then the left half of that, then the right half of what remains. That will specify exactly one seat, right? So the challenge in part 1 is to figure out what is the highest ID on the boarding pass. And an ID is defined as the row times 8 plus the row of seats you're in times the seat times 8 plus the seat number. What this basically all boils down to is they're just giving you a number in binary, but written in a slightly different way, right? So if F means to take the lower half of a section and B means to take the upper half of a section, then F is like a 0 and B is like a 1. So for example, we should get row 44 working through this. So is 44 the same as 0, 1, 0, 1, 1? Well, that would be 0, 1, 0, 0. So that would be what? 4 plus 8 plus 32 equals 44. So it's basically, once you sort of work through the logic of what you're telling you, they're basically telling you to like, hey, make sure you know how to work with binary numbers in your programming language. So we're going to basically calculate the highest binary number we see in our input data. And then in the second part of the challenge, we're going to say there's going to be, some list of numbers, not necessarily starting at 0, not necessarily going to anything maximum, but there's only going to be one number missing. What is it? Because that's the seat for you because you've lost your boarding pass. So let me show you how I solved it. Let me close some things off here and open day 5's solution. This is the whole thing. It's 5 lines of code total. I'm using the power of list comprehensions. Now, this first one here is maybe a step too far for making a list comprehension that's not as confusing as just a loop would be. But basically, I'm going to open my input text file and then make a new list using a list comprehension. I'm going to say my data is equal to this list, right? So I'm going to have some long, in this case, long expression. I'm going to have 4 line in file. So for every line in my file, add some manipulation of it to my list. And that's going to be the string 0b plus whatever's on that line, replacing f's and l's with zeros, and replacing b's and r's with ones to basically turn it into a binary number. Oh, and then I'm going to strip the new lines off the end, just because when strings come in, they sometimes have a new line at the end, and that throws off whether you can treat it as a number or not. But so then I'm going to basically redefine what my list is using this construct from Python, which allows you to sort of take in a string in a specific format and view it as a number. So rather than just casting my data, which is going to be 0b10100010, right? I don't want that to be 1,011,101, right? I want that to be a binary number. And so I say, hey, consider this as an integer, but in base 2. Right? Consider this as a binary number. So the data is now going to be equal to the binary number version of that number for that number in my list of existing data. And then I can use a couple more built-in functions to basically finish off part 1. I just print out the maximum value in my list using Python's built-in max function. So if I print that out, and I should make sure I'm running the right code. The solution to part 1 is 963. The highest value in my list, 963. Using the max function here really saves a lot of room. And then the solution to part 2, right, where we found the only missing number in our list, is just this one line here. So I'm saying solution to part 2 is, and then I'm using this list comprehension to solve this problem. I'll say mine, just the name I gave, it's gonna be my seat number, right? Could have called this variable anything. Mine for mine in range from the lowest value in my data to the highest value. And I want to make this the highest value plus 1 because, of course, range goes from the lower bound inclusive to the upper bound exclusive, right? So I want to go from, if I just said, 0 to 962, I wouldn't actually compare against 962. So I go minimum to data plus 1 if this value mine is not in my data. So I'm basically saying, okay, in this case, my minimum value is like 50 something. Is 51 in my list of numbers? Oh, it is. Can't be the right answer. Is 52 in my list of numbers? Oh, it is. And if it is, I'm not going to add it to the list. I'm only going to add it to the list if that value is not in my data. When I run that, I get that the only value that's not in that list is 592. Yeah? This sort of making sense? I hope so. These are sort of the ideal case for list comprehensions, right? This one up here is like, once it starts spilling beyond a single screen of text, it's a little bit much. But for something like, hey, I just need to take every item in this list and turn it into its binary equivalent, being able to express that in a really compact form is really handy. I want, hey, the data should be the base 2 version of the data, for every D in the data. Great, done. I want, every number in this range that's not in my data. Great, done. Just really fast and compact way to look at these things. Yeah? I'm gonna take one more question break before we dive into day 6. And yeah, we'll see what happens. Like I say, I have not looked at the problem set for day 6 at all yet. So you're going to see the whole process. We're going to muse on the solution together. You'll almost certainly see me go to Google and Google how to do something in Python. And we'll do some research. Maybe there's some data structures that we need that I don't know off the top of my head, and we'll just see what happens. So stand by for genuinely for questions. But you know what a question maker is. That's a big plane. I don't understand. Oh, on here? Because I'm not sure I understand. Maybe I've taken too many question breaks. A big plane. A big plane? Or a big plane? Plan? I don't know. Help me out, Chris. Help me out while I load up the day 6 question. All right. Oh. Oh. Thank you, Thaddeus. Yes, 596 is a lot of seats on a plane. Yes, I'm with you now. Yeah, I'd already jettisoned that question from my memory in preparation for the next one. Also, hi Thaddeus, nice to see you. I'm not sure we've seen you before, but welcome. We'll have a good time. All right, shall we check out day 6? Yeah, let's do it. Day 6. And like I say, I'm going to read the text on screen here. I don't know if that's the most comfortable for everyone watching out there. If you go to adventofcode.com, you can read it for yourself if that's more comfortable. Day 6. Custom customs. As your flight approaches the regional airport, well, you'll switch to a much larger plane. Oh, a much larger plane? Yeah, we're going to have like a spruce goose of a vacation here. A much larger plane. Customs declaration forms are distributed to the passengers. The form asks a series of 26 yes or no questions marked lowercase a through lowercase z. All you need to do is identify the questions for which anyone in your group answers yes. Since your group is just you, this doesn't take very long. However, the person sitting next to you seems to be experiencing a language barrier and asks if you can help. For each of the people in their group, you write down the questions. For each of the people in their group, you write down the questions for which they answer yes, one per line. For example, ABCX, ABCY, ABCZ. In this group, there are 6 questions to which anyone answered yes. A, B, C, X, Y, Z. Duplicate answers to the same question don't count extra. Each question counts at most once. Okay? That seems fair. So, okay, so what they're giving us here is basically a unit test. They say, if this was your input, then there are exactly 6 questions to which anyone answered yes, A, B, C, X, Y, and Z, right? Another group asks for your help, then another, and eventually you collect the answers from every group on the plane, your puzzle input. Aha, okay, we'll take a look at that in a second. Each group's answers are separated by a blank line, and within each group, each person's answers are on a single line. For example, okay, so here's some trial input for us to play around with. So this group would be just one person who answered A, B, and C, yes, then a space, right? So this is a new group. In this group, each person only answered one question, said A for the first person, B for the second, then per a group of 2 with A, B, and C, A, and then a last group of just B. And then it clarifies down here in case you haven't. They've really done a nice job of like explaining this if you didn't have context for like what it meant to be a boarding group on a plane, and what answers you should get if you parsed these out. In this example, the sum of these counts is 3 plus 3 plus 3 plus 1 plus 1. So in the first group, ABC, 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 then just A, then B. So 3 plus 3 plus 3 plus 1 plus 1 is 11. For each group, count the number of questions to which anyone answered yes. What is the sum of your counts? To begin, get your puzzle input. All right, well, this seems very reasonable. So the first thing I'm going to do, I guess I'll pull my puzzle input up here. Yeah, so of course it's much, much, much longer than those little sample examples they gave us. But that's all very good. Before I start putting anything into my code, I'm going to start a new Git branch. So I'm going to call this day, capitalize these, day 6. I guess I'm going to git checkout. I know this text is small and that I apologize for. Git checkout master, git branch day 6. Just so my code is, and then I'm going to do git checkout day 6. Just so my code is ending up in the right place in my Git repository. All right, so now that I've done that, I can come back to VS Code here. I'm going to close my other files, start a new folder. I'll call this folder day 6. And in that folder, I'm going to put a new file called input.txt and just paste the 2001 lines of input from our website here. I'm going to save that, and let's create a new Python file called day6.py. So what occurs to me here, so we want to count whether in between every pair of blank lines which letters are present and which ones are not, and count up that number of letters. So I think I already have a fairly concise way of solving this. But before I get to it, think for yourself about how you might go about starting to solve this problem, right? So we have these this long list of individual lines of individual letters, and we need to track within each group how many, basically, is any letter present or not, right? It doesn't matter if there's two S's or two Z's in here, just is any of them, is any particular one, is there a Z or no? Is there any Z or not? Yeah? So just give yourself a moment to think about how you might solve it. I've been being a little bit primed by a solution to a previous day, which also had groups split apart by blank lines. That I think is leading me to a solution that looks like... This is the other cool thing about Advent of Code, is that they're two-part questions, so you don't get to see the second part until you've solved the first part. So if you take shortcuts on the first part, you sometimes don't get to take them in part two. So the solution that's coming to mind, that I would talk through more, because I think it's going to be more clear if I start typing it out, might be a little bit too shortcutty and might come back to bite us, but we shall see. So let's get our data into a place we can use it. And really, what I'm seeing here is, because for this point it only matters whether there's any particular letter in a particular group, I don't actually have to keep these individual lines separated, at least in this question for part one. Like this would be the same input whether it was 4 lines of people or one contiguous line of people. So what I'm going to do is say with open input.txt, and in fact, before we run it on our full input, let's get some of that sample input from our problem statement, and we'll use it to validate our code before we actually run it. So we will make a new text file called input_test.txt, input_test.txt, and we'll use that first. Open that in read mode as in file. And we will say data equals, let's see, how do we want to do this? Group for, let's see. I really would like to split this. Okay. I'm going to make use of a Python function that I don't know that we've seen yet before, which is join, which takes all the elements of a list and smacks them together. So if I just join, let's see, line 4. So I'm going to sort of build up this line piece by piece. Line in file. So basically going to smash all of these lines together into one contiguous string. No sense of lines, everything in there. Of course, our new line characters, which are part of this text, will still be there. So here, let me show you what this looks like. So if I just print this out, and again, we're running on this little dinky test file as opposed to our full, problem set input. Let me get over to the right folder, cd day 6, and Python day 6. So you see, even though I've smashed all those strings together into one contiguous line, it's still printing them out with these spaces in between them because these new line characters that are a part of my input file are still being printed out to the screen as line returns, right? But what this is going to allow me to do is once I have that, I can split that string apart, and I want to split it whenever there are 2 new lines next to each other. And in case whenever there's a new line followed immediately by another new line, or put another way, whenever there's a blank line. So if I run this, I should get, I should print it out so we see something. When I run this, I should get, so I now have a list of the individual groupings. Now there's still some new lines, hanging about in here, but that's okay. We won't be bothered too much by them. So this first group ABC is just the line ABC. This second line here, A, new line B, new line C, is this second group. AB, new line AC, right? Because again, this \n is a new line, right? That represents our third group here, and so on. And so while I still have these obnoxious new lines hanging around, what I've done is basically compile each of the groups into its own object in a list, which is great, because we're asking questions about members of this list. And now I have the list row separated by groups. So let's see, let's leave that data there. And really what I want to ask is which of the letters are present in that line. So let's give ourselves a list of letters to work with. I'll say letters equals A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. I think I got them all. I hope so. Here, we can figure that out pretty easily. Let's put the length of our letter string. Yeah, I got 26. Okay, that's a good sign. I think that's how many there are. What I'm going to do now is, let's see, still print our data out, but I will say print sum. I'll use the built-in Python sum function. I want to sum up the total number of these of, let's see, count, I think is our, let's see, what's our count function actually called? String.count. Okay, so I'm going to sum up a list comprehension. I'm biting off more than I can chew at one time. So I've got my group split apart by list. What's the number, the presence of each letter in each list is going to be, let's do this as a for loop, and then we can compress it just for cleanliness. I'll say for group in data, for L in letters, we'll say count equals 0. For L in my letters list, if L in group, count plus equals 1. We'll need a sum item up here. We'll say sum equals 0. And we will say sum plus equals our count for individual group. And I will print out my sum at the end of things. So if I run this, something's gone wrong. I get only 5. I should get, let's see, for group in data for L in letters, if L in group, count plus, sum plus equals count is what it should have been. There we go. So now I get, this is the nice thing about having some of that test data that provided us, right? I should have 11 unique letters. So I get 3 unique letters from the first one, 3 from the second, 3 from the third, 1, and 1 should be 11. And they gave us another set of test data, yeah? Let's see. I guess in this first one here, so let's think about this. In this first example, ABCX, ABCY, ABCZ should be 4 plus 4 plus 4, so the answer should be 12. So let's validate that real quick. We'll just put that into our input test file here. And when we run our main program, I get 6. That doesn't seem right to me. I'll make sure I copy and paste that right. So I should get, this is 4, and this is 4. Because the groups would be separated by new lines. That's why. So it was treating it as there were 6 unique letters in that big group, but if I run these properly with them as separate groups in this input, I get 12. So that's a good sign. All right. So in theory, now this should run and give us our actual answer. What I like to do, what I think I'm going to do is validate this against the full text list, and then I want to try and compress it to a list comprehension, because this feels like there should be a nice compact way of expressing this, and I think we will maybe learn something about doing it. But let's switch this input test.txt to just be input.txt and see what number comes back. I get 6,310. This is the part. This is the part of that where I'm really hanging myself out on the line, because we'll see if I did this right. Hey, that's the right answer. I'm 1 gold star closer to saving my vacation. Very good. All right, before we continue to part 2, let's compactify this a little bit. So I'm going to say, let's try and turn this into a list comprehension. So let's save this solution here. You can always come back to it. And let's revert to our input test file here. And I will say print the solution to part 1 is, and then we will use our f strings here to just put it right in. The string version of the length of a list. Ooh, Nate's got a gold star. Excellent, yeah. Solution to part 1 is string of the length of the list. And I want this list in here is going to be basically the intermediate results from processing our data. So I want for every item in this group, what I'd really like to get is the count of unique letters in it. So for that, I'm going to say, let's do a little shorthand here. letter count for group in data, right? So this is what I'm essentially going to create, is for every group in my data, for every group of tickets, I'm going to determine the number of unique letters in it, and then I'm going to take the sum, sorry, not the length, the sum of all those items and return it. Now I just have to flesh out how to do this letter counting. And to do that, let's see. I think I could do a nested comprehension, but do I want to? For letter in letters for... So the way you handle nested loops, the same way we might do like for in our day 2 code up here, right? We did our, I guess in our day 1 code, we did these nested for loops. We did for I in a range, for j in a range, for k in a range. For list comprehension, you can do the same thing. You can say for, you know, I in something, for j in something, for letter in letters, for group in data. And I want, what does this letter count function want to be? It wants to be the sum of the unique letters. Oh, I could say, let's put this inside parentheses just for clarity. I could say 1 if letter in group for letter in letters for group in data. I think that's right. I might have some syntax errors here. Yeah, I definitely do. So let's see. I'm missing a parentheses here. I'm missing a quote. It's because this is an F string. Let's try that again. 1 if letter in group, else 0. Invalid syntax. Let's see. Where's my missing brackets? Oh, because I have a string function here. Yes. So I think I'm missing a close parentheses. Oh no, I wasn't. So this is this sum function here should have parentheses around it because it's a function. Int object is not callable. That's a bad sign. Here, let's break this apart a little bit before we jump into the deep end. Let's create this list and do it correctly, and then we can sum it up. So let's say print this list. All right, so what this is doing, should the quote be after is? No, Nate, good question. The F string doesn't, basically everything wants to be inside of quotes. When we put this F out here to sort of automatically turn anything in curly braces into a string, the quotes go around the whole thing. I guess let me just print out the sum of this list here. Int type object is not callable. Why? Maybe the sum function doesn't work the way I think it does. This is not uncommon for me in these challenges. Like, I think I know how this function works. No, there's something I don't know about it. Let's see how this. Let's go to the internet and see how the sum function works. It does not take a start argument. Sum of the iterable. Yeah, that's what I thought I would have gotten. So I basically have built this list here, which I think represents the data correctly, although I'm not 100% sure. And I was just trying to have it sum those all... Oh, no, interesting. It did... One if letter in group, else 0. For letter in letters, for group in data. Yeah? So here, let me comment out my upper problem solving here. Just so I'm not confusing myself with other things being printed out. Comment that out. Yes, so this is our input data list. The something is so Nate. Oh, Nate, there is something I don't know about. It's so good. It's very good. Cheers. It's very good. I have nothing to say. So let's, instead of just immediately printing this out, let's just say, my list equals this list, and print my list, print sum my list. This is 12. And 12 is the right answer. That's good. So why was... Oh, maybe I was putting the sum in the wrong place? Int. Oh, it's interesting. The error is now... What? So when I run this code, it works just fine. Oh. I think I was just putting the sum function in the wrong place. I think it was basically a typo. So let's see if we can... So now that we know that this list is being created how I think it does, let's just copy that back into, let's just double check the formatting down here. String, I guess I don't need this string function. Just sum of that list. Run it. Solution to part 1 is 12. And 12 is not a solution to part 1, but that is the correct methodology here. So if we change this back to input, we should get that same 6310 just like before. Very good. So just to recap a little bit here, Nate Palmer approves. Yeah, it was Nate, like, kudos, man. That's next level. So what I'm doing here is using a list comprehension to generate a list that says, all right, this list is going to be composed of the number 1 if a letter is in a group, as letter ranges over all the letter in letters, right? And remember, letters is just A through Z up here. There's probably some Pythonic way to generate the numbers A through Z, but I don't know what it is. And it's going to loop over all of the letters and all the groups in my data and put a 1 in this list if the letter is in that group and a 0 in the list if that letter is not in that group. And then it's going to sum those all up at the end, and the total answer was just like before, 6310. Yeah? So, I don't know. Looking at how long this is, I don't know that this answer is necessarily better than this one with 2 for loops, because they do the same thing, and this one might be clearer. It honestly probably depends on your style, right? Like, this is certainly more compact, but this one might be a little bit more verbose, which is not necessarily a bad thing. This is also just, as part of the like process of, showing the work, as it were, here. So like, I originally tried to just write it all out into a list comprehension here, and something wasn't working. So I started breaking it down into individual parts. Okay, well, I don't know if the sum or the printing is weird. All right, just get the list out here and make sure the list is right. And that sort of led me to, oh, the list is right. I was just sort of summing it up wrong. I was printing it wrong. But when you run into problems like that, a good thing to do is to start, like, rather than jumping right into the deep end of trying to do everything in one line, break it down into a few parts. Neat. Well, that's going to be my solution to part 1. Shall we see what part 2 is? Part 2s have a way of throwing a curveball into your solutions to part 1. So here we go. Part 2. As you finish the last group's customs declaration, you notice that you misread one word in the instructions. You don't need to identify the question to which anyone answered yes. You need to identify the questions to which everyone answered yes. Ah, okay. Using the same example as above, the list represents data from 5 groups. So in the first group, all one person answered yes to A, B, and C, so that's worth 3. In the second group, there is no question to which everyone answered yes, so this group is worth 0. This group would presumably then be worth 1, 1, and 1. Let's see. Everyone answered yes to question 1. Some people did not answer yes to question B or C, so no. So in this group, yes. So we have 3, 0, 1, 1, 1. So the answer would be 6. For each group, count the number of questions to which everyone answered yes, and what is the sum of those counts. Cool. Yeah, so this is classic advent of code. It's like, the same input for both parts of a day, a little tweak to the second one that might make things just a little bit more complicated. So let's go back to our code, and we'll figure out day 2. So we already have this data broken down by groups, but that's not going to be what we want anymore, right? Because now it does matter which answers are in which line. So let me clear out some of these comments, and some of we'll leave that for now. Let's just let's put a comment in here with our I was almost at our hashtag symbol because I guess I'm a millennial. This is day 6, part 1, and down here this is going to be day 6, part 2. So let's just reload our data so we're not confusing ourselves. I'll say with open input. Let's start with our test text this time. Input test.text as in file, #. Thank you, Chris. Yes, octothorpe, I think, is the other term for that symbol. But this time, instead of joining everything together and then splitting it by blank lines, what I really want is, let's see, how do we want to break this up? You know what I could do is join these all together and split them up by line, and then I could say data equals, let's see, d dot split on new lines. I guess this is really group dot split is probably more evocative. Group dot split on new line characters for group in data. Yeah, okay, and let's print this out to make sure I'm getting this right. So this time, oops, whoa, oh, we're still running day 1. Here we go. Let's comment out that print solution there. Let's see, what else are we printing? Get out of here, print statements. Print. Okay. So now, rather than having sort of a list of all the characters per group, now we're going to sort of have to keep each of the individual participants in that group separate. So let's bring this back in as our test text and just double check. Yeah, so now I have, some lists that only have one element, but each of these little individual sublists, so this is just A, B, C, this is a list A, B, C, A, B, and C, Now I can sort of treat each of these individual lists as an individual group. And so now I can craft a solution based on that. So I could say, so let's do this, let's sort of do this again as a for loop, and then we'll do it as a list comprehension. So I'll say for group in data, for letter in letters, let's see. If this actually might be a little bit easier to write as a list comprehension and actually to expand it. I'll say I'll make a new list that says score equals a new list which is 1 for 1 if this is interesting. So what I think I'm going to generate is first a letters present list, which is 1 if letter in what are these called? These passports or these tickets? Oh, boarding forms in form for form in group, right? Let me put some parentheses around this to make it a little bit more clear. So this should, for every member of our group, we're going to make a list, basically 26 member group for every boarding pass that we are, every immigration form, I think these are. So if the letter is present in that boarding form, it will be a 1 in that position and a 0 otherwise. So let's just print letters present for now. Oops. For forming group, for letter in letters for, yeah, so we should get a bunch of lists of length 26. So this first one here, this first list corresponds to the first line of our input file, ABC. So we have 111, ABC, yeah. The next list here, so no, this is not right. For group in data, for pass in group. Oh, but I can't call it pass because pass means something else in Python. For form in group, letters present is a sublist representing whether the letters are in that group. All right, so, oh, and then we should print it right away. Yeah. So we should have 11 different lines here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. Yes, okay. So this first line represents ABC, right? So A1, B1, C1, no other letters. Then just A, just B, just C. Then AB, AC. And then this one is what? A, and then B. And that corresponds to our input text. Yeah, okay. So they're not printing out in any specific way. And in fact, I could print a blank line in between groups. That might clear things up a little bit. Oops. If I run the right bit of code. Yeah, so now I've put some blank lines in between the groups. So here's a group, here's a group, here's a group. And now what we're saying is not whether a letter is present in any position, but whether that letter is present sort of in all of these groups. So what I will say is once I've generated these lists, let's see, group list equals list, and I will append group list dot append that sublist we made. And now after we generate each group, let's print our group list out. This should be very similar to what we had a moment ago. Yeah, so now we have a list of lists for each group. So this list, that first group again, is just one entry, ABC, A, B, C. Then we have a list that represents A, and a list that represents B, and a list that represents C, and so on. And now I'm able to use those lists to determine something. I guess I didn't really need to turn them into lists of numbers in this case, but I think in my ultimate way of solving this, having them as zeros or ones will be helpful. So let's give ourselves a sum to work to. So sum equals 0, and I will say, once I've generated this group, I will say sum plus equals. So let's see. So we first need to determine how many items are ones in all of the members of each individual group. So once I've looped over all the forms for G in group list, I really want to loop over all the positions. So for L in range 25, or 26, I guess. There's 26 letters in the alphabet, you may not know. If group, let's see, I'm thinking and talking at the same time. Sum plus equals 1 if group, let's see, if G equals if G0 equals 1 for, this is a weird construction, for G in, yeah. What I want to use, I've kind of constructed this backward. I've really just turned these strings into numbers. It's not exactly helping me. Oh, you know what I could do is say scores equals G0. What I really want is to like multiply all of the first elements together and all the second elements together and all the third elements together. So if all of them are 1, the product is 1, or if any of them are 0, the product is 0. That's not the most Pythonic way to do it, but it's not a bad one. I'm just trying to think if there's what the compact way of doing that is. For I, let's do the slow way. Let's get a solution that we can make it more clean. For I in range 26, let's make our score list. Score list I equals, here, let's say, let's initialize them all to 1 with a list comprehension equals 1 for I in range 26. So now we have a list of 26 ones, and then for I in range 26, score list I, let's see, let's loop over all of our groups for G in group list, score list I times equals group list I. And print sum score list. Yeah, I feel like I'm just rambling a little bit here. Oh, need a colon there, need a colon there. Let's see, score list I. Oh, I need an indent there. Group list is not defined because I probably have camel cased it. Yes, group list. List index out of range. Sorry, this should be not group list I, but GI. Int object is not, it's the same thing again. S equals sum score list, print S. Int object is not, what am I not, let's just hear, what am I'm clearly not understanding something about how the sum function works. Let's just print out the score list. Something is not being created correctly here. And I probably don't want to print my other lists here. So in this case, okay. So the first group, which is just ABC, has A and B and C are all answered for the same, are all valid. The next group, A, B, C, should be all zeros. Then just A is the only common yes between those. Then just A, then just B. So we should have A, B, C, yes, there we go. Nothing, A, and B. So these lists are being generated correctly. Oh, so this is actually still a list of lists. That's why this sum was not calculating, right? Sum. So I really want to print out the sum of the sum of S for S in score list. No, I guess I can just do that. As long as I'm doing for loops, I could put the sum in here. I could say sum equals 0, sum plus equals score list I. This is a very non-Pythonic way to solve this, and it's making me a little crazy. At the end of this, we'll print out our sum, and then we'll have to come back and clean this up some. You know why it is? Is because I can't use the word sum as my total up here, because sum is a function in Python. Let's call this running total instead. You can't use names of built-in functions as variables, or things get very broken. There we go. 3, 1, 1, 1, 1. Oh. Yes, this is all happening within a larger loop, which is not what I wanted either. Let's see. Running total equals 0. For I in 26, for G in group list, running total plus equals score list I. Now it's just returning the last value. So what's happening here? I'm just confusing myself about my data structure, right? I've made it too complicated, and I haven't been doing good comments to tell myself what each of these things is. So let's see. So at this point in the code, right, I have, and it's all within this, for group in data, group list. Oh, and I'm also here, I've misassigned sum up here as well. That's no good. Did I do that up here? Is that my whole problem? Yeah, because I was using the word sum to represent my intermediate result. And that you can't do. So let's think about this here. For group in data, create an empty list. For every form in that group, so for every individual line item that we made up here, add a new list to that group, and that list will have 1 if that letter is in that form, for letter and letters. So this will turn each of the forms in that group into a list representing the letters that are in it. And then it will generate a list of ones and a running total. And for, so I need a new total up here. Group, let's see, let's call this result equals 0. Running total equals 0. Running total plus equals score list, and result plus equals running total, and print the result. Okay, and I should get 6 again. Yeah, because I have 3 for this first one, none for the second one, 1, 1, and 1. So that is correct still. All right, so thank you for bearing with. I hope this is useful. I don't think I'm explaining it nearly as well as I did when I've got physical things to show y'all, but let's walk through this algorithm again now that I've sort of shown you now that I've gotten to a thing that hopefully will work. So we took our data in from our test file. Then we used these 2 lines to split it apart. So rather than having individual lines, each of our groups is represented as a list, each of our boarding groups, and each of those groups, each of those lists is a list of the letters in that particular boarding pass. Here, let's as I do this, I'm going to import my exit function from sys import exit, and I can just print some things out as we go along, and then I will exit so we're not printing extraneous things, right? So import the exit function. So I took my input group, and rather than having it be individual lines, now I have a list of lists, and each of those smaller lists is just the individual lines of our boarding group, right? A slightly easier form of data to work with, right? Then I'm going to need a variable to hold that's the sum total result that I'm going to type into the website ultimately. And for every group in my data, right, so for every of these sublists, I'm going to start a new list, and to that I'm going to add, for every element in that list, a new list representing the state, whether each individual letter A, B, C, or D is in my word. So this string AB turns into the list 11000000. The AC is 101000, and so on, just to make things a little bit easier to work with. Then I initialize a list of all ones, or 26 ones really, and going over all of the letters. I guess this could just be for range in len letters. That might be a little bit cleaner. And for every group in my list of these lists of numbers, I'm going to multiply that letter indice by the number in my smaller list of numbers, right? So if there's a 1 in every position of these shorter lists, right? So if everything in that group has a 1, this will be 1 times 1 times 1 times 1 times 1, and the end result will be a 1. If any of them are 0, or in other words, if that letter is missing from any of my boarding passes, this result will be 0. Either way, I'll add a 1 or a 0 to my running total for this boarding group, and then when I have the total for my boarding group, I will add that to my grand results, and at the end, I will print out my grand result. And I will say the solution to part 2 is, quotes, result, and I'll make this an F string. So of course, we're still running this on test data and not real data. There we go. Solution to part 2 is 6. Great. Which is not. So let's run it on our actual input and see what happens. All right, so fingers crossed. So the answer is 3193. So what's going to happen next is I'm going to type this into the website. Hopefully we've gotten it right. It's just a brief sanity check. It's good that this number is less than our solution to part 1, right? Because this is the sum of the boarding groups where there's any letter in them. This is a more restrictive condition where the letter has to be present in all of the boarding passes. So it's good that this number is smaller. I'm going to type it in. Hopefully it's right. And if it is, I do want to go back and find a cleaner way to solve this problem, because I feel like there must be one. 3193. Hey, it's the right answer. I'm 1 gold star closer to my vacation. So currently 12 gold stars. We're really building out a nice little picture over here. Ooh, and we're only 2.5 hours from the next problem coming out. We will not be here that late. I'm not staying up to see this next one live. So let me think here. I think that these two lines are probably still useful to us in turning our data into individual lists of lists that represent, oops, let's go back to our test file here, just so we have something smaller to work with, right? Turning into lists of lists here. And really, what I want to say is, I want to loop over all those groups, and I think I can make use of, do you get it to try again if the answer is wrong, says Chris? You do. There's a required delay. I think it's a minute before you're allowed to try a next answer, which kind of prevents you from like guessing and checking. That's partly to do with the fact that like Advent of Code is also a contest. So you get points on the leaderboard if you're the first 100 people to solve it, I think, in a given day. That would mean staying up till 11 p.m. and then furiously coding. And as you've seen, I'm a little bit faster when I'm not talking it out loud, but not that fast. So yeah, so you can certainly try again. You have to wait a little bit. So let's see here. So, I think there's a way to do this with a list comprehension. I just have to think there is. For group in data is how it would start. It might be a little bit of a silly long group, list comprehension, but I don't really love, like, this step of turning the letters into numbers is kind of kludgy, especially when we have Python functions like in, like to check if a letter is in something. There's also a couple of cool Python functions that I guess we probably haven't seen. Let me reopen that Scratch file I was playing with a moment ago. Scratch. Sorry, I'm gonna blow away everybody's cool points. At least comment them out. And to show you the any and all function. So the any function returns true for if any of the items in a list that you give it are true. So in this case, if I print, oops, I should cd Python Scratch. 126 Scratch, I called this. Yeah. Is not subscriptable, right? Because this has to be wrapped in parentheses because it's a function, right? So if I apply the any function to this list, true, false, 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 I get a true value because any of them are true. It's only if all of the values are false. It's kind of like the or function in logic, right? If any of them are true, the result is true. And that makes it a good name for the any function. Sort of the equivalent of and is the all function, which is only true if all of its inputs are true. So true, false, false, false is false. True, 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 false is still false. Only if all of its inputs are true is true. Yeah, Nate's got 2 gold stars. Yeah, I get it. That's awesome. Yeah, the troubleshooting can be kind of the fun part, right? Of like, oh, how did what's going on here? Nice. That's awesome. So using, there's no need to see the tiny bit of keyboard there. That's a little silly. Using functions like any and all, I'm just like feeling that this should make our lives a little bit easier. Something like, if, let's see, one if all letter in form else 0 for letter in letters for form in group. For group in data, print this out and then exit. I'm kind of finding it honestly just a little bit hard to talk and type these things at the same time, but but I should be running this code and not that Scratch code still. So we'll change directories back into day 6, and we will run this code. Gotta have the proper indentation. Bool object is not iterable. Oh, I've put these, yeah, so all has to take a list. Letter in form for form in group, else 0, for group in letter in form for form in group for letter in data, for letter in letters, in letters. Yeah, is that what I want? Yeah, that's what I want. So, yeah, okay. Now I'm cooking some brain juice. So let's go through this expression here, right? So for every, we'll do this just for an individual group. So the list ABC, the list of A, then B, then C. Right, so we're just working within a single one of these. This expression here, so is a list comprehension, and it's going to be letter in form, right? So this in statement is going to be either true or false. Either the letter is in the letters of the string of an individual form, or it's not. So if the letter, if a given letter is in that form for form and group, right? So we'll form the list of true and false values for any given letter. Is it in those forms? If it's true for all those forms for a particular letter, we get a 1. Otherwise, we get a 0, right? So if this letter is A, and A is in the form for a particular form in a group, then the element of our list is inferior. Here, let me type this out. Let's do this with our group AB and AC, right? So we're going to iterate over all of our letter in letters. So we start with the letter A, right? And we're first going to form a list which says letter in form for form in group. So first, it's going to form the list true, true, because A is in this string in the group, and A is in this form in the group. Now we evaluate the all function on this. So we say all true, true. And this is, not proper code. I'm sort of typing out what we're doing in step here. So all of true and true, right? Well, that's true, right? All those are true. So true is true, true, right? So I say 1 if this statement, otherwise 0, right? So, okay, so all those were true. So that's going to create a 1. This is also within a list comprehension. So the first element of our list is going to be 1, right? And then we continue iterating all of the letters that we have on our list. So now I go through with B. I say, is it true for all in that this list B in form for form and group? So let's make that sublist. That sublist is going to be B is in the first form, but it's not in the second form. So all of true and false yields false, right? Now I say 1 if this expression, right? 1 if all of this, but no, that was false. So otherwise I put a 0 there. So now my list looks like 1, 0, right? And we can do the same with C, right? This C would be, in this case, here, we can put some comments in here. We can say this was for the letter A, this is for the letter B, and this is our forming list, as we say. So after that, it was 1. After this was 1, then a 0, and so on. Then for the letter C, right, we say, okay, is letter in form for form in group? So that list is going to be, in this case, false, true, because our statement is AB and AC. So all of false, true is false. So our list now looks like 1, 0, 0, and so on. And there's no other letters to really consider. So our list ends up being 1, 0, 0, 1, and so on. And then we take that and we print it out, and we can see that should correspond to, that was this list here. So that's 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. Yeah? So what I want to do is now, to get my final score, I want to sum up each of these lists, and then I want to sum those things together, okay? So, delete this example here. So now let's say, let me print just the, but I can't, so if I just sum these individual lists, so this will give me, when I print this out, rather than printing out all the lists, it will just print each of the sums. So, but that's okay. So I get 3, 0, 1, 1, 1, right? So there's 3 letters here that are valid, none here, just A, just B, so we're good. And then I want to get the sum of that. So I will say, rather than putting this for loop outside, let's use another list comprehension. So I will say print sum of the list, sum of all these things, for group in data. And I should get the answer. Syntax. I'm missing a close parenthesis here. No, this always happens when these things get too long. So print open curly bracket. I always get these wrong. Hang on. Let's see here. So let's go back. Let's back ourselves up a few steps to a thing that worked, and we'll work forward again. So save that, run it. Still wrong. But this should not be a list. Name group. Right, because this was originally for group in data. All right, so yeah, so there's our individual numbers. So what I'd really like is, first, before we try and sum it up, let's make a list of those numbers. So let me wrap all of this, and let me see, that should be inside of that curly brace here. So I'll wrap all of that in square brackets, and I will say for group in data. So now I should just get a list of those numbers, 3, 0, 1, 1, 1, and now I can just take the sum of that list. So we'll put that in parentheses, and we'll take the sum of it as 6, which is accurate. And then I will just say print the solution to part 2 is, and we'll wrap this. This is one of the nice things about, and Sublime Text will do this too, but VS Code is really nice. If you highlight a long stretch of code, and then type like an open parenthesis or an open curly bracket or what have you, it will automatically put the matching bracket at the other end of your selection. So what I just did there was like select everything I wanted to be inside brackets and then hit the brackets key, and it put the closing bracket in for me, which is quite nice. So now say solution to part 2 is 6. And if I... so I still have an exit statement down here. So let us do the following. Let's not print our data out anymore, but let's change our input file back to our proper input file, and hopefully we get, result is not defined. I must have deleted it as part of this. Result equals 0, and let's rerun this code. I make the same solution twice, yes. So this one line of code, which again, I'm not arguing is better, it's just shorter. And really, I think, as I said at the beginning, like part of my goals for Advent of Code are stretching my thought processes in this way. So like I don't know that this is necessarily a good way to write this code, but it does work. So these this one line of code is doing the exact same thing as all of these lines of code. Doesn't make it better, but it just was the way I wanted to stretch myself here. So what would be let's do one more thing. What would be a happy medium? Let's say first solution. Let's make this the third solution because it's going to be the longest. So now that we have a working one, let's say, let's break this solution back apart a little bit. So let's say, let's make an intermediate list called group scores that is just the individual, let's see, which is this inner list, I think? Yeah. Probably didn't want to cut that out. I wanted to say paste it, and let's print group scores. So I like, oops. And letters, for group in data. So one way that we might make this clearer, he said, hoping it becomes is like to break this initial very, very long line back apart into some of what it's actually doing. So these are the scores for the individual lines. Because if you ran across this, the point of like trying to make this clear is like if somebody ran across this code for the first time, would they be able to sort of work through and tell what it does? And like, yeah, you could work through this line, but it starts with two sum functions. Like that's a little bit verbose. So what I'm trying to do now is like, how do I break this down just a little bit so that's a little bit more readable and make our second solution, our in-between solution. Let's see. And it might be a combination of like combining, like going back to a for loop. So I can say for group in data. Let's see, result equals 0. I can say group score equals, and I want to take away this outer loop. But leave the sum function, I think. And I will say result plus equals group score and print result. 3193, 3193, 3193. Yeah. So, and if I was just going into a code base, I might make this even clearer by doing something like def letter in all forms that takes a parameter called group, and I could say return all, basically return this statement, return if letter in all forms, group else 0. We should get that same, I should take a group and a letter. There we go. So I think of all the solutions, this sort of long one where we broke the individual loops apart, and this first one here that I crammed the entire solution into one line, I actually think this is probably the best solution because I think it's the most readable. So I define this function, right? So it takes a letter and a group and says, is it true that that letter is in that form for every form in the group? All right, that's a fairly tractable function, right? So I need this letter to be everywhere. Then I'm going to start a result counter at 0, and for every group in my data, its score is the sum of the fact that the letter is on all of the forms for every single letter, right? So we go through all the letters and see is that letter in all the forms, and sum those, get 1 point per letter, add that to my group score, that group score to my running total, and then sum up their result. So like, I think if I were to write this in a place where like I might need to actually revisit it at a later date, this second solution is probably the best. This is probably the kind of code I would write as I was like figuring out how to approach the problem. This one I wrote honestly just for me. I hope you learned something from it by like watching me struggle to like put this syntax together. But this is too unreasonably long to be functional, right? This is really, look how far off the screen it is, you know, even at a relatively small text size, it's just not parsable. So I think something like this, and you know, it's a matter of style, like do you actually want to break this out into a separate function? Was it more clear if you just leave it in line? I'm not entirely sure, but I think this is really parsable, right? You know, all letter in form for form and group, great. And then this is really parsable, right? 1, if the letter is in all the forms, going over all the letters and add those up. And, you know, 6 or 7, like lines of code doesn't really matter. Clarity and, you know, time efficiency do. So this is the way I would probably choose to approach it. And that's D6. That's D6 in a nutshell. Questions? I know it's a little bit of a strange night in terms of the context of this channel, but fun, I guess, kind of interesting. What I'm learning is it is difficult to talk and type at the same time in an effective manner. I think we learned that back in Arduino days as well. Yeah, I hope it was helpful. Oh, Thomas, hi. Been following your Demolight project on Reddit for about a year now and working on your own mini mover. Oh, very cool. Excellent. Glad to finally catch you live. Thanks, Thomas. Yeah, awesome. Were you the one who recently, who recently updated your flare on Reddit? If that makes any sense. If it is you, that will make sense. If it's not you, then don't worry about it. But there's someone on Reddit who's been working. Yeah, it is you. Hey, amazing, Thomas. Nice to see you here. Yeah, I'm glad you could catch us. Chris says, can you rubber belly and pat your head? Sure, but I can't do it on stream for legal reasons. I don't know. Yeah, I don't know that I would necessarily. This was interesting and fun, and I hope people learn some things. I don't know that it is the best way to learn code, but as with when we started this back in March, no one really knows the best way to learn code, and live streaming may or may not be it. But so some takeaways, even with all my rambling, some takeaways from tonight that I think we can sort of go back and reflect on, right? So we learned a few things about list comprehension. I hope this was educational in the sense of bodging together, and this is perfectly fine working code, but it's just a little bit verbose in terms of how I sort of went about solving it. But sometimes you gotta bodge your way to a solution, and by doing that certainly helped me internalize what was going on in the problem, and get the structure of the letters interacting with the forms, interacting with the groups into my head, and that helped me sort of approach this in a more structured fashion. And that's partly why I like the process of reading a problem statement or getting a project into my head and then letting it germinate for a little while, especially if it's gonna have to do with creating a new structure for data. I think back to this QList control project that I've referenced before, to control the plane at the museum I work at, where, to make a long story short, I had sort of the list of queues to be executed stored in one list in the program, which was fine, and I wanted to give that program the ability to run multiple lists at the same time, or at least store them separately. So I had to take what essentially was a Python list and turn it into a list of lists, or have basically a list of objects, and those objects were objects that had could have a name and a last modified date and parameters like that. And that involved a fairly significant rewrite of my code. So when I was working on this, I just I started thinking about it while I was sitting on my computer, and then I went for a half-hour walk and just tossed things around in my head. I was like, hey, is this a list of lists? Maybe is it a dictionary that holds these queue lists and they're referenced by the name, but then we're kind of tied to the name? That doesn't seem right. Or is it a dictionary stored by some kind of reference number? And just kick the problem around in my head for a little while. I find really helps me architect these kind of things. And certainly, doing it live when not having any rev up time, that architecting time was kind of doing this code out, just kicking this solution around in my head. Having some DMX issues back here. I'm having some, you probably have always seen, I have some flashing going on in the background here. I'm not entirely sure what's going on there, but, it's always good to have a problem to troubleshoot. Yeah, I think that's where we're going to leave the Advent of Code for tonight. Hope this was certainly different and fun. We will be back next week, Sunday, 7 p.m. Central, here doing more Demolight stuff. I got the notification yesterday. My circuit boards will be arriving from JLC PCB on Tuesday. So that will give me a little bit more of a run-up to make sure that they don't catch fire before next Sunday night's stream. I think I'm going to try and get them assembled, a few of them assembled a little bit ahead of time. We can do a little bit of playing around with them. I think it'll be a lot of fun. I'm really hoping that these circuit boards, which will be version 0.94, are good enough for me to feel good about releasing the files for. There's two sort of big features I still think need to be added, but as long as they're sort of workable and don't catch fire, which is not always a given, I think I'll feel good about at least putting them out there, especially, if people are making their own of these things. You take on a certain amount of ownership over solving challenges, or at least I want to lay out what those problems would be. I think we're going to be in a good place. So yeah, so Demi-Lights next week, and then and then this would be a good time to preview. So So today is December the 6th. 2 weeks from now will be December the 20th. We'll be right in the run-up to Christmas. Not that I'm going anywhere this year because it's 2020, but the holidays are traditionally kind of both a busy time for us, might be a busy time at work, getting ready for some last-minute holiday things that we're doing virtually, and also just like a nice time to spend time with my wife and my dog. So I'm going to take a little brief diversion from Python in 2 weeks from now and do just a one-off introduction to Fusion 360. I've talked before, maybe doing a series on 3D printing, streams on 3D printing. There's honestly a lot of really great 3D printing content out there, and a lot of content on all these things out there, but that's not why I'm here. But I have enough people in my life who I know have Fusion 360. I know Chris works with it. God, Palmer says you could make a slightly bigger version of the light and call it Demi Moore. So we're gonna take a brief diversion into Fusion 360. And do like a one-night introduction to, because I know a lot of people who are interested in like getting into it and using it, and a lot of folks who are working in Tinkercad, which is a great program, or Onshape. I think Fusion is really a great program for 3D printable draftings. So if you're interested in learning Fusion or learning a little bit more, if you have just gotten a 3D printer, or you are maybe hoping to get a 3D printer for Christmas, or cash with which you could buy a 3D printer, be a fun night for us to hang out together. We, of course, won't go deep in the paint on the Fusion 360 topics, because it'll be just, one night, couple of hours, but enough to get people started on some key concepts that by the end of it, you should be able to make some pretty significant objects and at least understand the interface enough well to get into that. That, I think, is like a good way to lead into the Christmas season. It's a thing I don't have to prepare too much code for in advance, which helps me around the holidays. And I think it'll be fun. I think we'll have a good time. If we do it right, and I'm not quite sure what this object would be. So my 3D printer is, you might be able to see it on this camera, just up here. The thing that says this unit is controlled by a wall thermostat. Is that guy. My thought would be, of course, I'm not giving away a free printer. I wish. Yeah, like, comment, and subscribe, and you'll see the videos. You'll see the streams. My dream would be to figure out an object that is like interesting to draft. Do that in 75 minutes, let's say, as an introduction. A small object so that then we could print it in like 20 minutes on stream while we look at some more Fusion features, and then look at our printed object together and like see some of the features. Now, the fact that I'm like focusing on it as a 3D printing methodology, Fusion is good for a lot of things besides 3D printing. But if you're thinking about making physical objects, you need to have a sense of what your tolerances are in your manufacturing process, right? Is it making something by hand and hand filing it? Is it doing it on a CNC mill? And your tolerances are really good there, but you have to think about work holding and sort of things. So there are certain parameters to your object creation depending on your manufacturing method of choice, and 3D printing is just the one that I know best and will be able to reference and show you. The lessons will be useful whether you're 3D printing or not, but when I'm like, okay, so I'm gonna make the whole, the size of this bolt plus 0.2 millimeters on the radius, that's because I know my 3D printer will do a bolt hole to within a tolerance of 0.2 millimeters, things like that. It's good to have a tolerance gauge. So that's where I'm coming from in terms of choosing that as a thing. Needs Prusa to sponsor me? I will take it. Joseph, if you're out there, if you want to sponsor, some electronics bash and some printing, I'm always here. More on that to come. Not actual sponsorship, just Prusa products, because I'm a nerd and I love the Prusa Mini. Let's call it, y'all. Let's wrap it up. Thank you so much. Thanks you for joining me here on these Sunday nights. It is so delightful to be here, even when it ends up kind of rambly and hard to do. It's fun to share the challenges with people. I really, really enjoy it. It's a privilege to be here. I really appreciate it. I hope you're using this as a time to like build strategies and keep doing good things out in the world there. Thank you, Palmer. Thank you, Katie, Nate, Chris, Thaddeus, Thomas. Good to see you here. Yeah, it's really great. I hope you're staying hydrated. I hope you're staying safe. Hope you're staying home. Hope you're staying well. I'm Jeff Glass. If you have questions, or if you dive into Advent of Code, I know Nate's getting stars already. If you have questions or like want to reach out during the weeks, the easiest place to get me is on Twitter. Twitter's over here at Jeffers Glass. Happy to like talk it through. All the code from tonight will be on GitHub, link in the description. All of the my thoughts on writing the code are on my blog, jeff.glass/blog. all this stuff. You're all great. Thank you, nerds. And I will see you next Sunday night for more mini moving lights, and with a little luck, less fire than last week. I'll see you around. Thanks, y'all.